Welcome back. We are looking at section 12.2 on the graph of exponential functions. And these last two sections are intended to be really very simple introduction into the type of work, again, that you're going to be doing once you get to Math 102. So we aren't going to go into these sections very deeply. However, what I am going to detail is what I'm going to be looking for when you do these questions in your homework. You're not going to have so many questions to do in your homework on this. I think it's fewer than 10 actually. But the type of work I'm looking for when you're doing these type of questions should be detailed in a few ways. So let's go ahead and start by taking a look at exactly what makes an exponential function exponential. So first off, we start with what we're going to call kind of our generic function, which is going to be y equals 2 to the x. So what makes a function exponential is that the variable is in the exponent. So it's not going to be in a numerator, it's not going to be a denominator. The variable itself is going to be the exponent, or will be part of the exponent. So what am I going to be looking for in terms of the homework here? So first off, in this section, you'll find that the problems in the book, the problems you'll see online, they may define things as f of x equals 2 to the x or y equals 2 to the x, but they generally tend to stick to y. I think probably just because it's an introduction, but you certainly could write y equals 2 to the x as f of x equals 2 to the x, and it would represent the same thing essentially here. So in terms of what I expect on your homework, there are a few things. One, you need to write the problem. So you need to write what the function is, so write function. And you're also going to need what I'm going to call, again, graphable points. And these are points that should fit within the confines of a normal 10 by 10 graph. Here you see where we have x going from negative 10 to 10 and y going from negative 10 to 10. So, and when I'm looking at graphable points, I'm looking at 4 to 5. So it should definitely show the trend of where the graph is going. You may not always be able to get 5, but certainly at least 4 graphable points that demonstrate the nature and the direction what's happening with the function here. So I'm not going to graph all of these by hand, and we're not going to produce tables for every one of these within the context of the lesson. We will do these with maybe 2 or 3 because the procedure for using a table is essentially the same across the board. But we will have to be concerned about finding what are the proper values to use, proper values of x to use when we're developing this table. But for the moment here, we're going to go ahead and we're just going to pick we'll start off with 5 here. So we're going to start by creating a table for the function that we have here. And we'll go ahead and start here. So we'll have x. And then we have the function 2 to the x, and then we'll have y. So that's going to give us a table of values here. So we'll go ahead with negative 2, negative 1, 0, 1, and 2. So I'm going to just kind of go to the numbers here without showing a lot of the work. It should be work that you are fairly comfortable with, but in case you are missing something, you don't quite get it, please feel free to flag me down in class. So this is going to be 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, and 2 to the second. So one thing you should notice here is, let's get this straightened out here. 2 to the second is equal to 4. 2 to the first is equal to 2. 2 to the 0 is equal to 1. What about 2 to the negative 1? So 2 to the negative 1 is, if you may put a 1 under the 2, you should get for this 1 over 2. Then 2 to the negative 2 is 1 over 2 squared, or 1 over 4. So we're going to take those points now, and the other thing I need you to include in the homework is the graph itself. And then, with lines, or with a line. So you're going to plot the points down, you're going to draw a line through it and show what the function is going to look like. And we're going to kind of treat this as the baseline. We're going to be showing what these look like on a graphing calculator. So let's go ahead and put these down now. Negative 2 1/4. That's pretty low, but it's not right on the line. 1 1/2 is right, or negative 1 1/2 is right there. 0 1 is right here. 1 and 2, that's going to be right here. 2 and 4 is going right here. And just for the purpose of kind of showing what happens next, if I put 3 in, 2 to the third, well, that's going to equal 8. And you should kind of see here that this starts to increase pretty rapidly. So when we talk about something, you may sometimes refer to hearing about things as growing exponentially. So there are different rates of exponential growth. Obviously in this case here, as you see, something starts off growing rather slow, but the rate of increase goes up rather quick. So this is essentially the basic graph of an exponential function. And we're going to go ahead and compare this now to the graph of other functions that come from the textbook. So we're going to start by taking a look at problem number 12. And this is going to be f of x is equal 4 to the x. Or we can just say y is equal to 4 to the x. So I've written the function down. The next thing I want to go ahead and do is to write a table of values. So I'm going to write this as x, 4 to the x, and then this will be y. So I'll go with negative 2, negative 1, 0, 1, and 2. That's going to be 4, negative 2, 4 to the negative 1, 4 to the 0, 4 to the 1, and 4 to the second. And you notice here that, yeah, that's not going to be plottable, but you got these 4 of the points which you can get down. This will be 1 over 4 squared to 1 over 16. That's really close to 0. Just put it close to the x-axis. This is going to be 1 over 4, 1, 4, and 16. So when you're putting this down, get it real close to the x-axis. Get this pretty close there too. It doesn't have to be exact. This is going to be 1. This is going to be 4. You can kind of throw this up here, approximate it, and you kind of see where this is going. It's going up, and it's going up very quickly. So one of the things that you'll find is the more and more you go to the left here, it will get closer to 0, but it actually never gets to touch the x-axis. Same is true with this one here. So one of the terms that you're going to hear is that the kind of line that's formed when you graph this exponential function, we're going to call this type of line an asymptote. A-S-Y-M-P-T-O-T-E. So we would say that the exponential function is asymptotic to the x-axis. So again, asymptotes are going to be something you learn about in greater detail in Math 102. But again, this is the type of work I'm looking for. So what am I looking for? Write the function. Give me graphable points that you like substitute in and put on here, and then finally graph the line for me. At least 4 points you can fit. Okay, so we have one more equation here, which is the graph of 6 to the x. And what we're going to do is we're going to go ahead and kind of graph this on graph paper, or put this on a graphing calculator now, and see what that looks like. So hopefully the lighting from the light will help us here. So we're going to type in first 2 to the x, or oops, not this. Next one is going to be 4 the x, and next one's going to be 6 to x. And we're just going to kind of compare to see what the difference is between these basic equations to get a feel of this. So for this one, we're going to use, oops, not here. We'll not use that kind of line. We'll use the turtle for this one. And for this one, we're going to use a thicker line. So y1 is going to have a generic line. y2 is going to have a thicker line. y3 is going to have the turtle. And we're going to create the window. And we're going to just make the y max here. We'll go ahead and make the y max 30. And this ought to give us a decent idea. And we'll go ahead and make we don't need the y min to be much more than negative 1. So we'll make that negative 1. Let's go ahead and see what the graph of these looks like now. So it's first going to graph the function y equals 2x. Then let's go ahead and graph the function y equals 4x. comes up a bigger line. Then we see the graph of the line y equals 6. You see it's kind of creeping up here. And what you find is the graph of y equals 2x goes up pretty fast. Then the graph of y equals 4x goes up even faster. And then the graph of y equals 6x even climbs at a faster rate. So as we change the value below, we find that this is going up faster, faster. So as we change the value that we're raising to the exponent, the higher that number, the faster the exponent's going to increase. More coming back in just a moment.